Okay, so in the first video we talked about the reason why we're doing literature search, which is basically to become an expert in the field. So the actual process of searching involves a number of steps, and generally there's an initial search where you use some kind of search engine or database, discipline-specific database lookup to get a handle on potentially interesting resources. I'll be talking largely about Google Scholar because that's widely available. Anyone with a web browser can use it. It also has a lot of information on it, and obviously when you're searching you want the background database to be comprehensive. You don't want to have a database that's only got half of the potential resources in it, so you won't find other stuff. Now even Google, of course, even though it scans the whole web to find information, it doesn't necessarily, or isn't necessarily going to find right up to the minute information, because the web crawlers that Google uses have a lot of crawling to do, and it may take several months before it actually reaches a resource that's been put online. So you're going to have to do some follow-up work as well. If you find some resources and they're a couple of years old, and this depends on the discipline. Maybe some disciplines you can deal with 10, 20-year-old papers and that's fine. But in some disciplines, like computer science, things change really fast, and you don't want to, if you can avoid it, be looking at papers that are 10 years old, because they've probably been well and truly superseded. So following up on those, finding out the more recent work in the area, starting from the point of the old, possibly classic papers, is something you need to do. Once you've found some useful resources, you need to keep them somewhere, and probably you need to annotate them as well. And you certainly want to keep them in a form where you can use them in citing them and referring to them in your research papers. Another useful thing with finding literature is finding out not just about papers, but about the people who work on the projects they're working on, the venues. I mentioned that last time. Things like Google Scholar can actually help you, actively help you in keeping up to date with how things are changing. Google Scholar can set up alerts where you effectively put in a query, and every day Google will run the query for you and give you all of the most recent stuff that it's found that matches that query. So that's a very handy way of tracking things. And nowadays social networking has become ubiquitous, and there are even growing websites that deal with research. One example of that is ResearchGate, so potentially getting onto those websites is useful as well. Okay, so I'll say a fair bit about Google Scholar. So that's the URL for Google Scholar. That's the Australian version. You can leave off the .au if you like. Google Scholar is very useful, and it's the sort of standard place that I start if I'm trying to find stuff out, but it really shouldn't be your only resource for searching. There are other resources, like the UNSW library has a whole bunch of discipline-specific databases that you can use. Particular areas may have their own databases as well. So in computer science, for example, the two standard resources would be the ACM Digital Library and IEEE Explore. Google Scholar has a massive advantage that the interface is dead simple. You don't have to learn Boolean querying strategies and so on. You can just get in, type a couple of keywords, and possibly get some interesting results. So here's an example of a query to Google Scholar. You can see that up the top you've got a box pretty much like Google. I've typed in a couple of keywords and notice that I've put them in double quotes. The reason I did that is if you don't put them in double quotes, each term is treated separately, and Google searches for articles that have either information or extraction or both. That's potentially, especially with a very common word like information, going to throw up millions and millions of matches which aren't really related to information extraction. So if I put the keywords in quotes, it'll search for that exact phrase. You can see that Google Scholar can search for articles. Now I'm looking at the sidebar. In the sidebar, you can see that at the moment it's giving me articles, research articles, journal papers, conference papers, and so on. But if you're doing law, you can search for case law. And the My Library thing means you can actually keep a collection of interesting things that you find inside Google Scholar itself, if you've got a Google account. The next thing in the sidebar you can see is that you've got filters on time, so you can decide I'm only interested in articles in the last couple of years, and you can say since 2014 or since 2011, or you can ask for all articles. You can sort them by relevance, and you can sort them by date. Clearly, if you're picking only recent articles, then sorting by date isn't that important. Google Scholar also indexes patents, and it also indexes just citations, not the actual article, but a citation to an article. Finding citations isn't potentially that interesting unless, I guess, the article didn't happen to be in Google Scholar. I normally uncheck including patents because they often don't show very interesting stuff. Right, if we look at the main search results, the title of the resource is given in blue. That's a link. If you click on that, it'll take you to another page where not necessarily will you have the article itself, but most likely, and in fact, that first article there, if you can see it on the video, its URL is dl.acm.org, which is the ACM digital library that I mentioned before. So if I were to click on that, on the blue link for that first reference, it would actually take me to a page that held all of the metadata for that. It would give me the title, the authors, give me more information about the authors than just their names, like I've got there. It would give me the entire abstract. It would tell me where it was published. So maybe, just maybe, using the abstract and the title and the authors to give you some quality measure, you might be able to work out whether you're interested in that paper. If you are, you need to be a little bit careful about where you're doing your search from. If you do your search from inside UNSW, UNSW has subscriptions to a lot of these websites, and once you're on the ACM, for example, on the ACM Digital Library page, you can actually get a copy of the PDF of the article straight away. If you're at home and you're doing it through your normal internet connection and you're not going through UNSW, it'll probably ask you to pay for it. So it's always worth coming into uni to do these searches and to get a hold of the resources. Other things that it gives you a little bit of the abstract. It gives you a little bit of context about where the keyword appeared. So you can see in the second match, it's got the word information extraction a couple of times. Also in the second match, you can see that the link will actually take you directly to a PDF for the article. So a lot of the time researchers will put articles on their web page, and Google will eventually index those. So you don't have to go through the publisher's page to get the information. Other interesting things here, it tells you the number of times that the article was cited. You can see that first article was cited 1,200 times, which means that it's a reasonably influential article. There's one further down that's cited 6,000 times, so that's clearly even more important. One thing about citation counts, though, is obviously they accumulate over time. And the fact that something has a citation count of 1,200 as opposed to 6,000 might simply mean that it's a more recent article. So, and you can see that first article is 2005. The article with 6,000 references is 1987. And in fact, the article with the 6,000 references isn't particularly relevant to this query. So you need to kind of make that decision just looking at the information given there. So, what else have we got? So another thing you can see is that there's a link called related articles, which will basically use all of the keywords in that particular match and go and find articles that have a lot of those keywords. So that's one way of getting related articles. The other way, of course, is to click on the cited by link, which will actually take you to all of the articles that's cited. this particular article. That's a very useful technique for following a classic article like the first one forward in time and finding out what other work people have done based on that. Very useful to get up to date in the topic. Okay, what other tips? Google Scholar will give you matches like Google does. It'll give you 10 per page. Don't stop after the first page. You may find 3 or 4 interesting ones on the first page, but that's not going to be the end of it. You probably want to go to the second and third page before you give up. You don't want to go to the 100th page. That's probably, you'll start to see that the articles become less and less relevant. Don't give up after don't think you're finished after one query and you found 4 interesting articles. Think of a different way of phrasing the query, use different keywords, use synonyms, add some more keywords to make the query more precise, to narrow the focus down. If you can't think of synonyms, then one potential way to do it is maybe to go to the Wikipedia article on the topic and look through there for other kind of keywords that are used in that article and then feed them back into Google Scholar. I already mentioned double quotes will make your search more precise. Google Scholar and Google generally ignore words like the and because they occur so frequently that they essentially have no filtering benefit. But if for some reason you need to include those kind of words, which are called stop words in the trade, you can use a plus symbol in your query to explicitly say plus THE, I insist on matching the word the in the article. And if you've got words that you want to exclude, for example, you want to ask a query apple, but you're not interested in apple the fruit, you're interested in apple the computer company, you could have your keywords as apple minus fruit, and that would potentially help with that. There are some very useful ways of qualifying the query, and in particular searching for authors. The way to do that in Google Scholar is to have author colon and then single initial and the family name in double quotes, and that will find articles by that particular author. And of course you can use that in conjunction with keywords to find all of the articles that this person has written on this topic. And may not have been obvious on that on this Google screenshot, but there's a little down arrow on the search bar. If you click on that, it'll give you a advanced search mechanism that gives you a whole lot of filters that Google Scholar understands that you can use to make your search more interesting. So don't miss that. Right, what else can we get from Google Scholar? Following up on initial references, I mentioned the cited by link. That allows you to work your way through how ideas have developed in this topic by finding out, here's an old classic paper, what is all the new work that's referred to that, presumably extending that work or going off in slightly different directions to that work. The other thing that you'll find as you chain your way through, so when you click on cited by, it'll give you another bunch of matches. They will also have cited by, so you can click on cited by, cited by, cited by, and work your way forwards in time from the original classic article. One thing you'll notice there is the kind of publication venues that keep cropping up for articles of that type. They might give you a hint on where to publish. Related articles is also a useful way of finding relevant works. Another thing that I didn't mention on the screenshot from Google Scholar, some of the authors were underlined. Those people have an author stats page that they've made public, and if you think that author is doing really interesting work, you can click on the author's title and it'll show you all their papers straight away, plus a whole bunch of other stats like citation counts and H-index and so on, if you find that stuff interesting. Okay, well, once you've got a whole bunch of, or as you're finding resources, you'll get a whole bunch of matches. Some of them will be useful, some of them won't. So we need some way of quickly evaluating whether we should consider a source further or whether we should just ignore it. One measure of how good a resource is where it's been published. In general, journal articles tend to be better refereed, therefore more complete, comprehensive, and probably generally better than conference papers, which typically have a single review. Journal articles often go through 2 or 3 reviewing steps. So journal articles will generally be higher quality. This is very, I'm making gross generalisations here, but journals will generally be higher quality than conferences, and tech reports haven't been peer reviewed at all typically, but they'll give you more recent work. So the quality is kind of being traded off against recency. So if you're really interested in bleeding edge work, look for tech reports, then conferences, and journals, as I mentioned in computer science, tend to be more archival resources. The other thing to consider when you find a paper is to try and find where the author, or in the case of a conference, where the editors or the program committee come from. It's probably slightly offensive to Ballarat Uni, but in general you'd find that if you've got an author who comes from MIT, the work is probably going to be more solid than work that comes from an author who's located at Ballarat Uni. So you get to know what are the very strong research institutions in a particular area, and you can generally consider that papers from those research institutions are going to be good. Another thing that you could consider is citation count, but I mentioned before that an extremely good, very recent work, despite the fact that it's extremely good, won't have many citations, whereas the old classic work on the topic will potentially have a lot of citations. Another thing about that is often the classic works, the ones with very large numbers of citations, talk about the problem in a way that's a little bit old-fashioned to the way it's discussed in more modern work. So the way people consider the problem, the way they describe the problem often changes over time, and the old classic works sometimes are a little bit old-fashioned. What else? Finding publication venues. Google Scholar will help you find potentially interesting places. You'll get journal names. If you type the journal name into Google, then you'll get the journal website, and there you can find interesting information about what kind of topics they consider, who the editors are. That will give you a bit of a feel on the quality of the journal, and you can often find tables of contents. There may be special issues that have a whole bunch of articles in the particular problem that you're working on. So that can be extremely handy. Similarly, you can find information about conferences. This information is potentially useful as you're getting to grips with the field, finding where do people publish, where are the good places that people publish, but also once you've completed your work and you want to publish, you need to know where these publication venues are. And as I've already mentioned, finding other researchers is very useful as well, because you can go to their homepage, and generally the simplest way to do that is to type their name in double quotes and the organisation name in double quotes if it's got multiple words into Google, and that will generally take you, as the first match will be their homepage. You can go to their homepage, it will give you often give you links to their publications, possibly links that aren't indexed by Google Scholar, but possibly more recent work as well. It'll tell you what projects they're working on and tell you what their graduate students are like. So that was a lot about Google Scholar and Google, which are clearly a useful resource. There are alternatives. As I mentioned before, the discipline-specific databases in the library are very useful, but there are other online free access sites, such as Microsoft has an academic research site which has a little bit of structure imposed on it. Google is basically a huge flat space, like a big bag of resources, and your keyword search is trying to illuminate the ones that are potentially interesting. If you want to navigate towards papers that are interesting, something like Microsoft Academic Research will give you topic areas and subtopics and sub-subtopics, and you can gradually work your way down to a collection of papers on a particular topic. Even though it has a little bit of structure, Microsoft Academic Research is still automatically constructed, so it has similar kind of problems to Google Scholar in getting names wrong. If there's a misspelling, it won't recognise it as being the same author, and so on. Microsoft Academic Research does have some very cute interface features, like you can pop up a researcher and get a graphical representation of their collaborators, and then click on one of the collaborators and get a graphical representation of their collaborators. Good way to waste a couple of hours. Okay, so then that's it for search and evaluating search results. So now, once you've found your resources, what do you actually do with them? That's what I'll talk about in the next talk.